Okay, let's go.
Wait, sorry.
It's okay. I'll just edit it.
Alright, so my name is Arik and this is Ryan.
Yo,
So today you just need to investigate
the Taylor
the Taylor series
series.
for
Oh,
cosine half x
yeah,
about x equals to pi. Ryan
yeah.
should answer below.
Okay. Introduction to.
Alright, so
Oh, sorry.
go ahead, dude. Go ahead.
Okay, okay. As you can see, the series of function fx about a point x equals to a is given by this whole string of whatever this thing is called, man. This whole thing. Okay.
So we just need to input in the values lah. So we just find the derivative of fx, the f prime x, f prime prime x, and
Yeah.
f prime 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 x. Then you sub in the value of x, which is about pi, and then we
Yep.
got those values
Okay.
lah. Then you input in using the Taylor series formula,
And then you
and
got this.
hence the Taylor series for cosine half x is
Yeah,
that.
that.
All right.
And then after that,
Um.
we will show the graph
So
later, but we'll proceed to the questions.
yeah. So after we input in the values into the website, we found out that the graphs don't look
The
exactly the same.
same when
Yeah. They
yeah, and
only. Uh,
they
yeah.
really look alike at x equals to 1.7 to x equals to 5. And more terms should be
Yes.
we think that more terms should be added into the formula so that you into the equation so that it will look much more similar to the original formula. And guess what we do? We did it. So we find even more and we put it into we write it down. We skip 4 and 6 is because
Six.
is
Yeah.
0.
Yeah. 4 and 6. F prime f like the 4. The derivative is 0 when you input in pi, and 6 also 0. So the only one with values are 5 and 7. So we just decided to use those terms
Yeah.
to make the graph more similar. Otherwise, we
Yes.
just be using 0, and then
Too long. Too
it's not
long.
very good.
Yeah.
Yeah.
Uh. Okay. Similarly, we will proceed to the questions first. Question and answers. Then after that, we will proceed to the graph. And from this new tail from oh sorry from the Taylor series from after we add in more values, we do see see the graph looks much more similar to each other, be it
Mm.
from negative 1.85 to 1.85 and 0.592 that at that point to 8 to negative 0.646. They are actually similar to get they are actually similar, so we can see that it has increased in its range of similarity. So
Yeah,
in
so
conclusion,
with more terms, the approximation of the Taylor series will become more similar to the original function. We know this because the range of the point of intersections of the graphs is now bigger when we add more terms. So that's why the approximation is now more similar lah to the original series.
yeah. And the three graph at intersects at x equals to pi is because when
When we just substitute x, wait, show the Taylor series. Go. Wait,
the which
so
one.
when we just substitute pi into when we just substitute pi into x, all of the graphs will be 0. So
Yeah,
that's why
so that's why they always intersect at
x
intersects at
equals to pi,
x. Yeah,
because all their values are the
because
same.
pi y equals to 0. And the graph, as you can see, oh, as you can see,
Uh,
the
so the blue line will be the first one
yeah,
with the
the blue
lesser
line
terms,
with the lesser terms, yeah, and
and
only
then the green is when we add more terms.
yeah,
Yeah, so notice how the graphs moves. towards the red line, which is the original function, when we add more terms to show that the approximation is now even more accurate to the original function.
So we can conclude that Taylor series do do really is really similar to the original function, and yeah, we it's quite
Yeah.
similar. In fact, it's actually very similar. Okay.
All right.
Thank you
That's
for
it.
your time, and
Okay.
hope you learned
Thanks,
something.
man.
Yeah. And hope to see you soon.